Hi there. So I thought of talking about something that's called fields. So I'm in a field actually. Oh, that's very interesting. I'm in an open field right now. So in science and physics also there is a concept called field. So I thought that is something very basic in physics. So we can talk about it. So before I talk about it, I'll just tell you what it is. If I keep a perfume in a room and I unseal it, that is, I break the seal, I let the perfume out in the open, exposed, the perfume will have its effect on the whole room, inside the whole room. Like the whole area of the room will be affected by the perfume. There will be a fragrance or a smell of the perfume throughout the room. So that we can say that when I enter the room itself, I will understand that there is a perfume in the room. So the perfume has its effect in the room, on the area around the area or the volume of the whole room. So same is the concept behind field. So we are not talking about perfumes in field. In physics, we talk about gravitational fields and electric fields and magnetic fields also. These three fields are the most commonly talked about fields in physics and science. I don't know if there are any more other fields, but I think there's only these three main fields: gravitational field, electric field, magnetic field. Yes. So I would like to tell about what is gravitational field. Gravitational field is the field or the effect in space that happens in space when there is a matter, because of a piece of matter, anything that has got weight and occupies space is what we call as matter. So any object, you can, instead of the word matter, maybe you can use the word object. Any physical object, anything, a block of wood, a piece of bead, or a tree, or a house, all these things are objects. So a stone, a rock, all these are objects. So any object, and these are all matter also. I like to call it matter. So any matter has got an effect on the space around it, and that effect is called gravitational field. So every object has got a gravitational field around it. So some gravitational fields are strong, some gravitational fields are weak. And how do we know what causes them to be small or big? So heavy things will have very strong gravitational field, and lighter things will have smaller gravitational field. That's basically how we understand it. So that's basically gravitational field. Any object will have an effect on the space around it, and that effect is called gravitational field. So gravitation is always associated with matter or objects. Now gravitational field of this house or this trees or any of these smaller objects are very negligible, very negligible. The gravitational field of earth, the gravitational field of the sun, very heavy objects, these gravitational field of planets, planetary objects, these things are really big, huge things. They have very high mass, they are massive. So gravitational field of these objects are the ones that matter. Matter, yeah. That so we only talk about gravitational fields of earth and sun and planets and etc. And then the next field I like to talk about is quickly electric fields. Now what brings electric field? So that you might have heard the word charges. So charge is something that you cannot see, something you cannot touch. Sometimes you cannot even feel it also. So an electric shock is not a charge. Electric shock is different. It's electricity. That's not charge. 1 minute, sorry. Yeah, he's inviting me to play badminton. Okay, this is his field actually. This is the place where he plays badminton. Okay, so there is this concept of charge. I'll tell you example of charge. Electron is a charge, proton is a charge. These two things are basically what are the main charges in the universe. I don't know if there are any other charges, but electron and proton, these are the main charges in the universe. So if an electron is there will be an effect around that electron, and that effect is called electric field. So the field due to charges is called electric field. Now, before it's too late, let me also tell you about magnetic field. A magnetic field is the field again due to charges itself, but it's not due to, I'll tell you the difference. Electric field is the field due to charges which are stationary, charges that are not moving, whereas magnetic field is the field due to charges that are in motion, charges that are moving. So that's basically it. Magnetic field due to charges that are in motion, electric field due to charges that are stationary, and gravitational field due to matter and objects and things. That's basically. Otherwise I'm stopping here. So I think the video is getting too long. I'll catch you later. I got a lot of things to say and share using this concept of fields. So I thought I would just say about fields right away and make it clear in the first place itself. Okay then, bye bye, tata.